right, so we are using the Topdon One on this 2015 Subaru. It came in for a P0171 engine to lean bank 1. Now, this particular vehicle is a little bit interesting. It only has one upstream sensor and one downstream sensor for oxygen sensors, and it actually does have 2 banks of cylinders. So sometimes troubleshooting these can be a little bit tricky since you don't have 2 different sensors, one on each side of the engine. So we're going to take you into the engine bay and show you what we got. So underneath the hood, we have the brake booster back here. There is a hose here going to the intake manifold. This is the intake manifold right here. We've got it clamped off currently. And basically what we have is a source of air leaking into the intake manifold when this is not clamped off. This is not supposed to return any air back to the manifold. And unfortunately, what is happening here is that's what's happening. So we have what we refer to as a false air leak. So basically, we have air entering the manifold that is not being measured by the mass airflow sensor, which is over here. So air is supposed to come in through the air intake, through the filter, be measured by the mass airflow sensor, and then the mass airflow sensor tells the engine control module how much air is going to enter through the throttle body here. Basically, we have air entering downstream of the mass airflow sensor that's not being measured by the mass airflow sensor, causing the engine to run lean. And that's why we have a P0171. Okay, so we're just going to show you for demonstration purposes. We've got the hose clamped off going to the brake booster. Here is our fuel trim. There's our short term. I'm going to slowly release the hose, the clamp, and look at that. There goes the short-term fuel trim as I am unscrewing the clamp right there. See that fuel trim change? I'll take you in a little closer. Right there. Now, if we go step on the brake pedal, this is going to shoot back up also. And even as we get back inside the car, we can see the short-term fuel trim actually had jumped as soon as we took the clamp off. So watch what happens. Here's your brake pedal switch input here, showing that we're stepping on the brake pedal. And here's your fuel trim up here for short term. Watch what happens when I step on the brake pedal. We should not be seeing this reaction in the fuel trim here when we step on the brake pedal, and we are. So when the hose is clamped off, nothing happens to the short-term fuel trim. When the hose is not clamped off and we step on the brake pedal, the fuel trim climbs, indicating that there is excess air or insufficient fuel. And because we clamp off that hose, we take away the excess air from the engine, which allows the trim to straighten out. So when I let off the brake pedal, eventually the vehicle will bring the trim back down to about 0 and everything will be fine. You can see the long-term trim also climbs over time when that hose is unblocked, indicating that it is in fact leaking unmetered or unmeasured air into the intake. So we're going to show you what a known good vehicle looks like now in comparison to that Subaru that we showed you that was broken. So if we look at, this is a percentage of 100, and that is our fuel trim from bank 1 to bank 2. This is a V engine, and it's a Nissan. Here's our mass airflow sensor here at idle, which is similar in grams per second to the displacement of the engine on this application. Here's our brake switch down here, showing when I press the brake pedal. And then we also have our engine speed right here. So you're going to watch. I'm going to hit the brake pedal. So we're going to watch down here on the bottom left. Hit the brake pedal. We do get a reaction in the fuel trim, but you notice it's very fast to recover. Now I'm still holding the brake pedal, and we are not seeing any reaction in RPM. We're not seeing any reaction in the fuel trim continuing, even though I'm still holding the brake pedal. On the Subaru, the fuel trim would continue to climb, saying that it was essentially receiving additional air that was not being measured. Here's our mass airflow sensor. Mass airflow sensor over here. I'm going to let off the brake. We're going to get a momentary reaction as that diaphragm gets refilled. There's your brake switch is now off. You see a quick minor reaction in the RPM. Again, correlated perfectly there. So about a 90 RPM change in idle for just an instant when the booster is refilled. And then we do it again. Almost no reaction and a super quick recovery. Let off. Reaction, quick recovery. Almost no reaction in the RPM, except when the reservoir is being refilled. So there you go. So this is a completely normal vehicle set up almost identically to the Subaru so that you can have a feel for, is the fuel trim going to change when you step on the brake pedal? Yes. But it's going to recover very quickly. And when you release the brake pedal, it's also going to react for just a moment, but it's going to recover quickly. If it stays positive, either when you press and hold the brake pedal or when you release the brake pedal, it stays high and it only interacts with the brake pedal input, then you need to investigate the brake booster, the hose going to the brake booster, the check valve in the brake booster, and any gaskets between the brake booster and where it mounts. So there you go.